Today we're going to take a look at an LG LCD TV and go through some of the tests that you can do to see if it's working. We'll start with the power supply. We'll start on the AC setting. If we check the mains, we should have 120 volts. And if you keep your probe on the neutral and then go to the other side of the main fuse, you should still have 120. That tells you have a good fuse. Then we'll check here at the filters. 120. Then of course this one, we'll check the output. 120. From here we'll switch to DC. Once we're set to DC, we'll check the bridge rectifiers. Those are good. When we check the main capacitor, we'll see that it has a higher voltage than the rest of the circuit up to here. That's because we have an oscillator circuit that is stepping the voltage up. In this case, we have 400. So our primary power supply is okay. So now we can move over to the secondary of the power supply, which in this case is anything to the right of this transformer. And while we're over here, you see the dotted line denoting that this is the hot chassis and this is the cold chassis. The cold chassis has a ground that is common to just about everything. The hot chassis is not grounded the same way. This has what they call a hot ground. So on the cold grounded side, we can find pretty much anything metal that's connected. And we'll start with some of these diodes. There we are. There's the 24 volt. There's another 24 volt, so that's good. This is the standby transformer. It's giving us 3.5 volts. This will be live when the TV is on or off. When the TV is off, this will not be live. Now that we're testing the cold side of the power supply, we can find a ground, usually on the LCD panel or somewhere similar. We'll check the backlight, 61 volts. We can also check here, right before the backlight connector. A lot of times the backlights will receive 61 volts or similar, depending on the size of the set, directly from the power supply. And then the ground on the backlight will modulate that for your dimming circuit. So if you measure the ground, you may get nothing, which is normal for fully bright lights. If you measure across, from power to ground, you'll get 61. That tells us that the backlights are fully bright at the moment. If they were dim, you may get closer to 50 or 40 volts, maybe as low as 20. But they're usually using the ground to modulate the brightness of the lights. From there, we can start to measure some of the outputs. That's a redundant 12 volt. That either gives us more current to the main board or a failure prevention in case one of these solders is bad. We can still have power. And there's a third. And a fourth. There's the standby. Looks like everything on this power supply is working properly. Finding the USBs on the set is the quickest way to check standby voltage, because most times they will be lit up even in standby. We can check the power to the LCD panel. We'll find a thicker line going to the LVDS. In this case, this is it. We get 16 volts to the LCD panel. That's running the scan ICs. And that tells us that we've got voltage right to the panel. Next, we have a Samsung TV with a more common failure. Besides the cracked screen, we have another failure that I want to show you. If we get really close, we can hear a squeal from the power supply. We'll start at the beginning. In the AC scale, if we check from neutral to line, we get 120. We check the output of the bridge rectifier right here. We get 160. Okay. If we check the main capacitor, we'll get 160. From here, we can find a ground. We'll start checking some other things. The 12-volt line looks good. There are two in parallel for extra current. The issue is this capacitor has failed. Let me get you a close-up. It is bubbled up at the top, which tells us that there is a short inside and it's overheating. Replacing that capacitor may have fixed the set other than the broken screen. There are several ways to tell if these are running. The first of which is to open up the optical port and see if there's a red light coming from inside. If there is, we know that the processor is running and probably transmitting audio. The other is we can check the backlights. In this model, there are a few holes in the chassis where you can see the backlight shine through. It's not actually flickering for me, but the camera sees the flicker. If the backlight is on, then we know the TV is operating somewhat. The set has a single channel backlight. We can check the voltage here. Has a very high voltage for a set this size. If the set is on, but it's not getting a picture, we can check the tcon voltage here. Should be around 12 to 14 volts. We can also check if this chip is warm. In this case it is. So we know the tcon is doing something. If that is the case, we can separate either of these two ribbons, see if it starts to operate. Most sets now will have half the tcon built into the panel, the other half built into the main board. If the set won't power up, you can remove this cable, try powering it up. It'll make the power up sound. If that is true, then we have most likely a bad LCD, which could cause this issue. In this case, we know we have a bad LCD. On some of these sets, you'll find that sometimes the Wi-Fi card will hold down the power supply. It is a USB Wi-Fi card. If you remove it, sometimes you'll be able to get the set to power on. I have just a few more Samsung-specific tricks that you can use. The first one is if you have a TV that will not turn on, remove the LVDS cable. It's got a little tab here. Pull it out. Then try to turn the TV on. You'll see the backlight comes on. That would tell you you have a bad LCD panel. Another good Samsung trick, if you have a TV that's dead and you're not sure if it's the main board or the power supply, you can remove the interconnect between the main and the power. Give it a little squeeze. That will force the power supply to come on. Now we can test it. Main capacitors are good. $12 volts. 12 volts. This is a good power supply. These are just a few simple tricks to make diagnosis easier.